Okay, the first question. Someone's in a hurry. They want to know, what is the turnaround time on stock items?
So the turnaround time for stock items is 4 to 6 weeks.
Okay. How much would it be for a custom item?
So if it's a custom item, it'll be about 8 to 10 weeks if we have the material on hand, or it'll be 10 to 12 if we need to get the material and the tooling created.
Okay. What are some of the types of exotic alloys you have in stock?
So some of the exotic alloys we have in stock are Hastelloy, Inconel, and
okay. The others?
Jake can speak a little bit more on that one.
Okay.
So in stock, we do have a good selection of Inconel X750 wire sizes. Usually for some of the more popular sizes of wave springs, say in the 1/2 inch to 4 inch range, we'll have a good amount of material that we can use in the Inconel range. Above there, we have select sizes, but one of the nice things about wave springs is there's multiple ways to make them. So if you're looking at a 5-inch spring with a certain force, we can make it out of a wider material, or we can make it out of a narrower material but increase the wave height. As Jimmy was mentioning when he talked about the multiple ways to make a spring. In terms of other materials we have on hand, 316, 302, 17.7, and carbon steel are our most common, and we're usually pretty well stocked on them. The other exotics, Elgiloy, Hastelloy, we don't stock them until we have a use for them, but then if you do place an order for a part that requires that material, we will usually then stock not a huge amount, but enough for if you came back with another order, we wouldn't then have to reorder material. One of the nice things about being privately owned is that we don't have to answer to quarterly stock reports. So we have large warehouses full of raw material, and we buy when the market's low, and we hold it, and then when the market price goes up for material, we use the material we have in stock and hopefully make it through, any minor increases in steel price or stainless price, but still offer a great price to the customer. The original question that was asked before I went off was what exotics we do have in stock. I mentioned the X750. We also have a good selection of A286 in stock, which is a high temperature application stainless. Gets up to around 1300 degrees without softening or big changes to its material properties. Do we have any other questions?
We have another materials related question. Are your wave spring RoHS compliant? RoHS.
So RoHS compliance, for those of you who don't know, is the restriction of hazardous substances. All of our material is RoHS compliant. On some of our tapered section parts, we offer cadmium or zinc finishes that are not RoHS compliant, but as wave springs aren't easily plated with cadmium or zinc dichromate, for example, as a general rule, every wave spring we manufacture is RoHS compliant.
Okay. What is the size of your engineering staff, support team, I should say?
So our tech sales group there's 6 of us in the U.S., and we have 1 tech sales person working out of the UK. In the U.S., our engineering staff is is a good question, but we have a decent team focused on different areas. Some of them are focused solely on designing parts and making sure our dies and stamping equipment works. Some of them are focused solely on finishes, plating, heat treating, making sure the factory runs, and then some of them are dedicated solely to tool design. In the Czech Republic, we have similar staffing for design of tools and maintenance of our facility there. And then our sales staff in Germany, one of our sales staff there is very well acquainted with Waive springs and is actually one of our most knowledgeable people on Waive springs.
Okay. How do Waive springs compare to coil springs in terms of cost?
So if you want to answer solely one spring versus another spring, the Waive spring will be more expensive 90% of the time. The cost savings come from the reduced application size, making a smaller housing, or removing a secondary operation. For example, on a really large coil spring or even a smaller coil spring, a lot of times there's a secondary operation involved to grind the ends of the spring so they lay flat against the retained surface or the mating surface. And there's also, as we saw in the applications that Jimmy was reviewing, an example of the mechanical seal, where the overall package complexity is decreased. You're not having to drill for individual springs, and you could use one Waive spring. So that one Waive spring is more expensive than the 12 coil springs, but the overall application is a lot less expensive. Likewise, with the downhole tool, the performance of the Waive spring is beneficial compared to the coil spring. So downtimes are are reduced, and when you're in the world of oil and gas, time is money. So saving an hour of time saves you, who knows, thousands of hours or thousands of dollars.
Okay, a similar question. How do Waive springs compare in cost to Belleville washers?
So the cost savings there is actually from a quality standpoint. Belleville washers are a stamped product, so generally they're less expensive than Waive springs. But if you're using a Belleville stack where you have, say, 4 or 5 Belleville washers and they have to be all installed in the application and they have to be installed in the correct orientation, you leave one of those out and no one notices it, now you have a quality callback. You may have to tear down an entire engine or an entire application to fix it. In the process, you may even destroy the entire application. We've all had that situation when we're working on a car where we wind up with 1 or 2 bolts left over, and you just hope they're not coming from somewhere useful. Imagine that on your assembly line, and at the end of the month, you have extra stock, and that wasn't supposed to happen. So now you may have a quality freeze on an entire lot of products. So the cost savings versus is in the quality department.
All right. What are some of the custom capabilities for Waive springs?
So custom capabilities is more custom capabilities. You're looking at Waive springs work in compression only, so you're not going to see some new design that has a wave spring being expanded, but the custom applications are really up to the customer and what they can come up with. Our design team works to make your application work. We try not to over-design anything. We, give you the part you need in the time frame you need it. Not sure if there's a specific question or a specific example that the questioner had in mind, but feel free to throw us another question.
Okay. What is the greatest axial load wave spring that you have ever made?
So, the greatest, that's not something I know offhand. We've done, that is something we could look back in our records. I know we go well over 1,000 pounds. Some of the examples where that high strength is, or where that high axial load is found, is in a nested wave spring, where instead of going crest to crest, you're lining up the waves, so you get a very short wave spring, but a very strong application. And I've worked on items in the 1,500 pound range there in about a half inch of space, or half inch for the work height, and that was on a valve application where I think it was a 6-inch valve, and you needed a really good force to hold the valve components in place.
Okay. How are wave springs delivered or packaged without them becoming wedged into each other or tangled?
So the wave springs themselves, some of them we do offer in shrink wrap stacks, especially the single turns can be offered that way. The multi-turn wave springs, stacking them is less beneficial because you throw 5 pieces in a stack and now you have a stack that's 5 inches long and can't really add too much more to that. For reference, when we stack tapered section or other flat parts, we're looking usually at a 50 to 250 pieces per stack. One thing we do find, though, I did a little work on figuring out box sizes for wave springs before we manufactured them, and I tried to find the packing efficiency for the boxes, and I went down to our warehouse, pulled a bunch of existing stock to test, and found that they didn't really want to tangle up too much, the multi-turns, because the ends are closed, the waves are, they're closed. It's not a coil spring where things could slip in between each other. So even if you do get a bit of tangling on 1 or 2 parts, they come apart immediately because they're not twisted together. They're just a little bit of overlap, and they separate, just like, I don't know a good example of something that separates.
All right, a similar question. Are there any difficulties in automating the installation of your springs?
It does depend on the application. Since we're not stacking these springs, since we're not stacking them, you sort of have to figure out a way to feed them into an automated assembly equipment. Beyond that, every application is different. So you may be able to work with a funnel to drop the spring in there and drop it into position, or there may be a better process for doing that. Rotor Clip does not design automated assembly equipment, but we can help you with figuring out the best way to approach the automated assembly.
Okay. Is there any way to prevent slippage or separation on a nested spring at high RPMs?
So on a nested wave spring, I assume this is a shaft operation, but as the RPMs increase, I wouldn't expect too much separation, especially if the spring is under load, because the axial load being applied to the spring would hold the waves in position. I guess if the spring came out of axial load, you might see a little bit of an effect, but honestly, that's not something I've ever come across. If there's a specific application in mind, you can definitely reach out to us after this webinar, and we can talk more specifically about the application in question.
Can you make progressive rate wave springs?
So one of the nice things about wave springs is the linear spring rate. I don't believe a progressive rate is possible. Once you go out of that linear region, you will see a little bit of a rate change, but that's also causing overcompression in the wave spring, which will then affect the spring once it returns to that linear region. Basically, you've now changed the the spring profile of the wave spring. So, short answer: progressive rates are not possible.
Okay, this sounds like one of my questions. Does RotorClip offer free samples?
The RotorClip offers free samples on stock parts. If you're looking at a custom design, we cannot offer free samples, but we can offer low volume prototyping, depending on the eventual project and depending on the size of the ring. That could be anywhere from a 5-piece minimum to a 100-piece minimum, and that's the nice thing about wave springs is we have all of our wire sizes in stock and the tooling that matches up to those wire sizes. So we designed the wave spring based on an existing wire size. That saves the customer time, saves you time on lead time, saves you cost because we already have the wire, so you're just paying for the wire you use, and we already have the tooling, so we manage to basically make the spring, since there's multiple ways to design one, we make the spring out of existing tooling and wire, allowing for low-cost prototypes when we can't offer a free sample. We do have full catalog lines of single-turn and multi-turn wave springs, both metric and inch. So if you are looking at an application where you would be interested in a free sample just to try something out, start with those products, and as long as they're not huge. If you're looking for a 2-inch part, 3-inch part, samples are readily available. 15-inch catalog part, less likely to be in stock, and we might have to charge you for a piece or two there.
Here's sort of an open-ended question. Is there anything on the horizon for new materials, new types of rotor clips, new shapes, new applications?
So RotorClip did just purchase a new machine that will allow us to get down to 3 millimeters and possibly below that on wave springs. One of the problems we're finding now is sourcing wire for parts that small, but we hope to have a wire supplier that can help us out with that, and basically that size we're looking, we're hoping to get the medical device and the medical industry as a partner at Rotor Clip, helping them with their applications as they're going smaller and smaller with their designs. We're going smaller and smaller with what we can do to help them out. Wave springs is one of those interesting places where making it bigger is a lot easier than making it smaller.
Okay. That's all the questions we have from our viewers. So that will conclude today's presentation. On behalf of Machine Design, I'd like to thank Rotor Clip for sponsoring today's event, and of course all of you for joining. Have a great rest of the day and a great weekend.